Hello, my name is Kyle Bloxham and I am a Senior Solutions Architect with AWS. Today's demo highlights how agents for Amazon Bedrock and Knowledge Base for Amazon Bedrock work together to provide automated task execution and efficient search capabilities for customer knowledge repositories. Agents and Knowledge Base for Amazon Bedrock build on existing enterprise resources. So you can use your existing business logic and customer authoritative data sources to power agent functionality. This insurance agent sample solution combines an agent and knowledge base from Amazon Bedrock to automate the insurance claim lifecycle. So the agent can perform actions like creating a new claim, sending pending document reminders, gathering claims evidence, and searching for information on existing claims as well as other data across a customer authoritative data repository stored in Amazon S3. We use Streamlit in this solution to launch an example front end intended to emulate what would be a customer's production application. To the right of the Streamlit app is our local terminal, so you can see the back-end processes of each front-end action. Our application provides two features. The first is the agent for Amazon Bedrock prompt input. This allows the user to invoke the agent using their own task input. And then there's the knowledge base for Amazon Bedrock file upload feature. So this enables the user to upload their local files to the Amazon S3 bucket that is being used as the data source for the customer's knowledge base. Once that file is uploaded, that feature, the file upload feature, starts an ingestion job to sync the knowledge base data source. We navigate to the Agents for Amazon Bedrock console and select our insurance agent. The agent overview provides metadata like the agent name, ID, description, and IAM role. If we scroll down, we see the working draft of our agent. Once you select the working draft, you will see the foundation model and instructions used to configure your agent. The model is the foundation model that your agent will use for React prompting as part of its reasoning process. And then the instructions outline the agent's intended functionality. So think of the instructions as part of the base prompt that the agent uses during its iterative React prompting reasoning process. This is the process where through an iterative series of thoughts, actions, and then observations, the agent reasons its way to a final response. The agent is equipped with a set of tools, some of which are referred to as action groups. So action groups are a set of APIs and corresponding business logic. Their open API schema is defined as JSON files stored in Amazon S3. And that schema is what allows the agent, along with the action group descriptions, to reason around the function of each API. Each action group can specify one or more API paths, and then those API paths' business logic is executed through the Lambda function that's associated with the action group. When we select the create claim action group, for example, we see that the action group is comprised of a description that allows the agent to identify what the action group is used for, and then we see the Lambda that contains the API business logic, the Open API schema in S3 that provides additional contextual details, all for the agent to understand the API functionality. Now, knowledge bases provide fully managed RAG capabilities, retrieval augmented generation capabilities, to supply the agent with access to your data. When we select our claims knowledge base, you will see that you configure the knowledge base by specifying a description that instructs the agent when to use your knowledge base. Hopping over to the knowledge base console for Amazon Bedrock and selecting our claims knowledge base to take a closer look at the configuration. In the knowledge base overview, you will see some configuration metadata, including the knowledge base name, ID, description, and IAM role. As part of your knowledge base configuration, we are building on existing customer knowledge base repositories, pointing the knowledge base to an Amazon S3 data source. We can cross-launch into the S3 console to view our S3 bucket contents. In our case, we initially have 9 objects that are a combination of documents that contain claim amounts, repair estimates, FAQ documents, and other informational documents. Jumping back to the knowledge base console and selecting our data source, we see its sync history. So when you create your knowledge base, you specify an existing vector store or you allow Bedrock to create the vector store on your behalf as part of the knowledge base configuration. If it creates one on your behalf, it's creating an OpenSearch serverless collection on your behalf to act as the vector store index. Once configured, each data source sync creates vector embeddings of your text data that's stored in S3 so that the agent can use those embeddings to return information to the user or augment subsequent foundation model prompts based off of similarity search comparisons. We see here that our original 9 objects are in sync with the knowledge base. Back to our Streamlit UI, we will start by uploading a claim amount document. So the Streamlit UI shows us that the file was successfully uploaded to S3 and the ingestion job status to sync the knowledge base data source is shown below. We can preview the claim amount document within the app. Here's a closer view of the document, which contains various vehicle, property, injury, and total claim amounts. With the document uploaded to S3 and the knowledge base in sync, we can now query the agent for the information contained within the document. We'll start with a query like, what is the total claim amount for claim ID 3B45C-9D? Now, behind the scenes, the agent identifies that it needs to use the knowledge base search tool, then performs a similarity search across documents using the text embeddings. We will discuss agent tracing in more detail towards the end of the demo. And we see the agent's response back that the total claim amount for claim ID specified is $86,130. We will follow up with another question using the contextual history that the agent possesses to just specify what is the vehicle claim amount for the same claim. We see the agent's response that the vehicle claim amount for the specified claim ID is $62,640. And we can validate those responses against the provided document for total claim amount and the vehicle claim amount. If we navigate back to the Amazon S3 console and refresh, we now see that we have 10 objects in our bucket, including the latest claims amount document. A similar refresh of our data source screen will show that the latest sync added a new file, all part of the knowledge base upload feature in our Streamlit app. Let's upload another document, this time a repair estimate document for the same claim. We see that the file uploads and the data source syncs. We can preview the document again and show you a closer glance at the document, which looks like this. And we'll start with a question about the repair estimate document with a question like, what is the repair estimate total for the same claim? The use case here being a human insurance agent wanting to compare two values across documents, making sure that the repair estimate total matches the vehicle claim amount total. And we see the agent's response that the repair estimate total for the specified claim is $62,640. Now we'll ask, and the repair estimate diagnosis for that same claim. The diagnosis for that specified claim is front-end collision, broken front axle, and shattered windshield. Finally, we'll ask, what about the repair estimate resolution for that same claim? And the agent responds that the resolution for that claim is that there is an insurance payout required. And we can validate the agent provided responses with the information contained in the repair estimate document. Now, imagine that the human insurance agent is assisting a client with their claims process, and the agent will like to query the company's internal FAQ documents to provide responses to the client's questions. For instance, how are policy premiums calculated based on the insured's driving history and claims record? Maybe the policyholder is worried about how a recent claim may affect their premium. And we see the agent's response that premiums are calculated using a proprietary algorithm that contains factors such as driving history, claims frequency, vehicle type, and location. An internal model analyzes historical data to assess risk and determine appropriate premium rates. So this would be an internal FAQ document response. One maybe we don't necessarily want to share externally with our clients, but allows us to educate the human insurance agent on our internal processes. The human agent may follow up with another question. In this case, in the event of a claim, what steps should agents follow to ensure a streamlined and efficient claims process? The agent responds, letting us know that agents should follow the internal claims handling protocol, initiating the process by collecting necessary information from the policyholder. This includes details about the incident, photos, and any supporting documents. The internal claims system then guides agents through each step, ensuring a smooth and efficient claims resolution. Now, what if we wanted to make similar FAQs externally available so clients have on demand self service access to the information that they need? Well, we can create a document that has the external FAQs contained in it. You see an example of such document here where we see the question, answer, and source URIs. We upload this document using the same workflow demonstrated previously through the file upload process. Then we can query the knowledge base once our data source is in sync, asking a question like, what factors determine my car insurance premium? The agent responds that the factors that determine your car insurance premium include your driving record, age, location, type of vehicle, coverage options, and more. Insurance companies use proprietary algorithms and models to analyze these factors and determine appropriate premium rates based on risk. Maybe I would follow up then as the client to ask another question. How can I lower my car insurance rates? The agent informs us that there are several ways you can potentially lower your car insurance rates, including maintaining a good driving record with no accidents or traffic violations, taking defensive driving courses, which may qualify you for a discount, bundling multiple insurance policies with the same provider, and qualifying for available discounts such as good student, safe driver, etc. You can speak with an agent to discuss options specific to your policy and eligibility for discount. Finally, if we navigate back to our Amazon S3 document repository, we now see that there are 12 objects, including the repair estimate for the specified claim and now the external insurance FAQ document. A view of the data source sync history shows 2 additional syncs, each of which have added one document, that being the repair estimate, then the external insurance FAQ document. Then to demonstrate action group functionality, we'll return to our Streamlit app and provide one final user input. In this case, the request to create a new claim. Based off this user input, the agent will identify that it needs to use the create claim action group, which corresponds to the create claim API path and corresponding business logic, ultimately returning the response that the agent has created a new claim with a unique ID, and the pending documents that need to be processed for that claim are the driver's license, registration, and evidence. Please upload these documents at your earliest convenience so we can proceed with processing your claim. Let me know if you have any other questions. A look at the agent's architecture shows us that users can provide their inputs using text to interact with the agent for Amazon Bedrock. Some of the sample prompts that we'd issue into here are things like create a new claim or send pending document reminders to the policyholder for a specific claim, or any one of the natural queries that you'd maybe use for the customer data repository. Things like what is the total repair estimate for a specific claim ID, or FAQ questions like how can I lower my insurance rates. During pre-processing, what you see as number 2 here in our workflow, The agent validates, contextualizes, and categorizes user input. So user input comes in the form of a task that's interpreted by the agent using its chat history and the instructions and underlying foundation model that were specified by the user during agent creation. So these instructions provide descriptive guidance to the agent on its intended actions and its ultimate purpose. During orchestration, step 3, the agent develops a rationale with logical steps of which action group API invocations and knowledge base queries are needed to generate an observation, and it iteratively goes through that React style prompting until it comes up with a final response for the user. The tools that the agent are using are action groups and knowledge bases. So action groups are a set of APIs and corresponding business logic where the open API schema is defined in JSON, stored in S3, and the business logic is executed through Lambda functions. Knowledge bases are that fully managed retrieval augmented generation capability that allows the agent to have access to customer specific data. So you specify an Amazon S3 data source that contains your document or knowledge repository, and then knowledge bases provide a managed vector store and create the vector embeddings themselves so that you can do similarity search across your document repository and align that with the user input. So you pull the most contextually relevant information and then augment the original base prompt with that information. Ultimately moving to step number 6, where once all orchestration iterations are complete, the agent creates a final response using the Amazon Bedrock foundation model on which the agent is built. Further examining the knowledge base architecture, we see that knowledge base functionality is delineated through 2 key processes. First, pre-processing, and then second is runtime execution. So during pre-processing, in step 1, the documents that are in the customer data source repository on Amazon S3, those documents undergo segmentation through what we call chunking so that the text in those documents is pulled into more manageable chunks. And then those chunks in step 2 are converted into embeddings using an Amazon Bedrock embedding model. Those embeddings are then utilized to create a vector index so we can perform semantic similarity comparisons between the incoming user inputs and the text that's stored in the data source that makes up the knowledge base. Then during runtime, the user provides their text input. That input is also transformed into vectors using that Amazon Bedrock embedding model. The vector index is queried for chunks related to that user query, and we augment the base prompt through that React prompting with additional context retrieved from the vector index. And then that augmented prompt, coupled with the additional context, is ultimately used to generate a response for the user. Once your knowledge base is created, you will navigate to the knowledge base console within the AWS Management Console. You'll see on the stack menu on the left, underneath orchestration is where you'll find knowledge base and agents. Selecting for knowledge base, you'll see your available knowledge bases. We'll navigate to the claims knowledge base, where we will see an overview of our knowledge base configuration. That includes the knowledge base name, the description that lets us know what the knowledge base is used for, the knowledge base ID, and then some other metadata stats around status and the created date and associated IAM role for the service. If we scroll down, we'll see the data source that's configured for this knowledge base, a claims data source that points to an S3 bucket. If I open the data source, I will see the name of the data source ID, and additional metadata. I also see the sync history. So as I add new documents to my Amazon S3 document repository, I will sync the knowledge base to make sure that the embeddings are up to date and stored in the managed vector store. In our case, an OpenSearch serverless collection. I'll navigate back to the knowledge base console, and I will see the test window for knowledge base. If the testing window is minimized, select the test option in the top right. You'll select your model that you want to use to interact with the knowledge base. In our case, we'll use Claude 2.1. Selecting that model, I then have the opportunity to perform some testing using some example queries on this knowledge base. This allows me to validate the functionality of the knowledge base before I integrate it with my agent. I can ask a question like, What is the diagnosis on the repair estimate for claim ID 2S34W-8X? I see the diagnosis for that on that repair estimate is a front-end collision and a broken radiator. I'll ask a question like, what is the resolution and repair estimate for that same claim? So the knowledge base has the ability to leverage conversation history and the document context in our knowledge base data source to provide the response that the claim ID of 2S34W-8X has a resolution of replacing the front bumper, hood, and radiator, and the repair estimate for the claim is $5,390. I also see footnotes here that allow me to further inspect the response. So I see the actual chunk from which the response was generated. I see that in both cases for the resolution as well as the total repair cost. And I can see the result details if I expand this, where I see the two chunks generated from the same document that have the relevant context within them. Again, sourced from this PDF document that contains the information that we just queried from the knowledge base, stored in Amazon S3. A look at the simulated repair estimate will show you in the notes for that estimate that the diagnosis is a front-end collision and broken radiator, along with additional notes around the cosmetic condition, the resolution, and the claim ID. We will continue with our testing, asking a question to the knowledge base like, what should the driver do after an accident? Assuming you're an insurance agent and you're in the process of responding to a client that maybe recently was in an accident and they're asking for the best practices after an accident. That data is stored in our FAQ document that's stored in Amazon S3 and accessed through the knowledge base. So we see here that the driver should first ensure everyone's safety, then exchange information with the other parties involved, take photos if possible, and file a police report. The driver should contact their insurance company immediately to report the incident and start the claim process. When we examine the result details here, we see that this contextual information is provided through the insurance FAQ document. The insurance FAQ document contains a series of 6 questions and their corresponding answers, where the question of what should I do after an accident and the corresponding answer are provided and read back to the user through the knowledge base query. Suppose the policyholder that's calling in reporting their accident is asking for the recommended accident report and image recommendations for the reporting purposes. You could also ask the knowledge base that question. The knowledge base query returns the results that for the accident report, it's recommended to include the date, time, and location of the accident, contact information of all parties involved, a description of the accident, how it occurred, and a police report if available. Alternatively, both parties can fill out an agreed statement of facts on motor vehicle accident form. For accident images, it is recommended to submit detailed photos of the accident scene, vehicles involved, and some additional information there. And again, we see the footnotes and can see the result details where we see the data source documents from which these chunks were generated. In this case, a Word doc file that shows the description for the accident report and a corresponding file for accident images that would mirror this same format. Suppose the policyholder then is concerned of their deductible and how that deductible will affect their ability to have an accident paid for by their insurer. So maybe they ask a question to the insurance agent like what is a deductible and how does it work? The agent can query the knowledge base for those details, assuming that those details are contained within an FAQ document in the customer's Amazon S3 document repository. In this case, we do have that FAQ document. So we see if we look at the result details, we're sourcing that relevant information from the FAQ document. And the knowledge base query responds that a deductible is the amount you're responsible for paying before your insurance coverage applies. For instance, if your deductible is $500 and the repair costs are $2,000, you pay $500 and your insurance covers the remaining $1,500. And that's it for testing our knowledge base functionality. Once we've confirmed knowledge base performance, we're comfortable integrating that knowledge base with the agent and we can perform end-to-end agent testing. For end-to-end agent testing, we first navigate to the Agents for Amazon Bedrock console. We select our insurance agent and are presented with the agent name, ID, description, and other metadata. Scrolling down, we select our working draft, which allows us to iteratively develop our agent. Our agent is configured with an Anthropic Claude 2.1 model and a set of instructions that define agent functionality and intended purpose. Beneath that, we see our 3 action groups in our knowledge base. The claims knowledge base is the one we just tested. Every time you modify your working draft, for instance, by changing the agent instructions, the agent console will alert you of the need to prepare your agent, which will package all of your agent's recent changes into a testable package. We prepare our agent and see the green banner confirming our agent has been prepared. Now we can begin testing in our testing window. First, testing the create claim action group. With the user input, create a new claim. The agent uses its instructions, conversation history, and set of available action group and knowledge base tools to complete the user request through React prompting. For each action group, the agent uses the action group description and API details included in the Open API schema to understand the action group's set of APIs and intended functionality. And then the agent uses the AWS Lambda-defined business logic to respond that it created a new personal automobile claim with a unique ID for the specific policy ID. The status is open, and there are 3 pending documents: driver's license, registration, and evidence. The policyholder receives an email sent through Amazon Simple Notification Service, or SNS, with their new claim information and a link to the claim evidence portal. The human insurance agent at this point may want to send a pending document reminder follow-up using the send reminder action group. Ultimately, a pending document reminder is sent to the policyholder using SNS and a unique tracking ID is provided. We will expand our testing window for further readability. We can evaluate the logical steps the agent follows by inspecting the agent's trace for each action group API invocation and knowledge base query. This provides a view into how the agent modifies the base prompt to the foundation model through its React prompting sequence. During pre-processing, we see the agent uses contextual conversation history to identify the relevant claim and the need to invoke the Notify Pending Documents API. There are 5 categories, A through E, into which the agent will categorize user input. For this particular case, we see the agent categorizes into category D, questions that can be answered or assisted by our function calling agent using only the functions it has been provided, and arguments from within the conversation history or relevant arguments it can gather using the ask user function. So the agent can follow up with clarifying questions direct to user. During orchestration, we see the step 1 API invocation and step 2 API response payload processing. Post-processing is inactive by default, so nothing is shown there. We will now test the agent knowledge base integration with a user query that will require the agent queries the knowledge base. What types of coverage do you offer? The human insurance agent might ask the agent for Amazon Bedrock this question so they can quickly provide an answer to the client during a customer service interaction. Or an organization can make this data directly accessible to their customer through a self-service on-demand model powered by agents and knowledge base for Amazon Bedrock. The agent response trace is, in this case, showing that during pre-processing, the agent identifies the need to query the knowledge base tool. Then during orchestration, we see that the knowledge base query occurs in step 1. In step 2, we see the context and full prompt passed to the Anthropic Claude 2.1 model. And then the query response in step 3 is shown. with post-processing still inactive by default. If we want to modify the default settings for agent pre-processing, orchestration, post-processing, and knowledge base generation, we can navigate to our working draft's advanced prompt settings and change any of their respective base template formats. And that's it for our end-to-end agent functionality testing. With some additional user acceptance, peak load, and other performance tests, your agent is well on its path to production. Thanks for watching.